Homogeneous catalysis. So when you see homogeneous, so you have to know homo means same. So what is same here? Same physical state. So what are same in physical state is between the reactants and the catalyst. So for example, reactant is aqueous, the catalyst is also in aqueous, then they are homogeneous. Okay, so if they are not same, then we call it heterogeneous. Okay, let's see. Catalyst and reactants in same physical state. And catalysts take part in reactions. So the catalyst will form intermediates with reactants, and the intermediate break down giving products. So catalysts take part in the reactions. Okay, so they form intermediate. So rate of reaction dependent on concentration of catalyst. So example, so that means your catalyst will be one of the part in the rate equation. Okay, so now example of homogeneous catalysis, iodine peroxo disulfate reaction. So iodine is the I2 lah, no? Peroxo disulfate is this thing lah. Okay, S2O82 minus. So you can see the mechanism here. S2O82 minus react with 2 iodide, become 2 sulfate plus iodine. So now this is slow step. So that means this is rate determining steps. Sometimes S2O8 is also known as thiosulfate. Okay, thiosulfate. Mechanism of the catalyzed reactions. That means, okay, this should not be the mechanism. This is the overall equation. This overall equation happens slowly. And because of that, they have to put catalyst to increase the speed of the reaction. So what reaction or what catalyst is used? They use iron 3. They add iron 3 to it, and then the mechanism will be as follow. So reaction 1, the catalyst react with the iodide become iodine, and then the catalyst reduce to iron 2, iron 3 ion to iron 2 ion. Okay, so it's a redox reaction. So iodide is oxidized and the catalyst is reduced. Now reaction 2, oxidations are iron 2 ions to iron 3 ions by S2O8 2 minus. So the other reactants react with iron 2, they form sulfate and iron 3. This is low activation EA, this is lower activation EA. Lower activation EA means they are fast, and this is slow. So this is the rate determining step. This is the fast steps. So that's why they have to draw it in this way. This is higher EA or low EA. Low EA, because low compared to this, this is higher in activation energy. Without catalyst, more energy, more activation energy. So now this is low, and this is lower in activation energy. Then they form product. Okay. So come back to the information here. They say they form intermediate. And intermediate breakdown giving product. So we have to know from these reaction 1 and 2, which one is intermediate. Intermediate is the one that is formed here and at the end used up to form something else. So which is iron 2. Intermediate is not exist in overall equation. This is overall, right? So iron 2, since it happens on the left, so we can cut out the iron 2. Iron 2 is intermediate. And iron 3, right? which use at the beginning and reform at the end. That is catalyst. So I write down the intermediate is iron 2. The catalyst is iron 3. So the difference is catalyst will reform at the end. Intermediate is used up at the end. Okay, so you can't see intermediate as the final product. Okay, now they form intermediates. As long as you are doing homogeneous catalyst, right, they form intermediate. And now let's see another example. Okay, so make sure you get the idea. The idea is, I write down in this way. In general, it looks like this. Reactant 1 plus catalyst form product 1 plus intermediate. Reactant 2 plus intermediate, they form product 2 plus catalyst. So make sure you see intermediate is here and here. Catalyst is here and here. Now when you want to do overall, right, you can cut away the catalyst, you can cut away the intermediate, and we have R1 plus R2 become product 1 and product 2. So in general, it's like that. Right? So where I is the intermediate. And then the C is the catalyst. Okay, now let's move on. Next part. Oxides of nitrogen and acid rains. So you can see this is the AS equation. Nitrogen monoxide plus O2 become nitrogen dioxide. So nitrogen dioxide, which is intermediate, this intermediate react with SO2 to form SO3. And NO come out again. So NO is the catalyst. It's the catalyst. Catalyst is reformed. Intermediate is used up. So once they found SO3, SO3 can then react with water to form H2SO4. So we learned this in AS. It's about the acid rains. Okay, now let's move on. The other side. Heterogeneous catalysis. Hetero means different physical states. So who has different physical state? It is actually the catalyst and the reactants. So for example, catalyst is solid, reactant is aqueous. Okay, example. So the catalyst has different role, not like just now. The catalyst will take part, will react with one of the reactants to form some intermediate. That is what happens to homogeneous catalysis. But heterogeneous catalysis, right? The catalyst has different role. Catalyst provides surface on which reaction occurs. They provide a platform or a surface. Okay, so reactant particle absorb. Remember this word. This word is absorb. It's not the normal absorb AB. This is AD. AD. Absorb. That means they stick on the surface. Absorb is like go through the solid. Absorb. But this adsorb, right? AD. ADSOR. So this adsorb is stick on the surface only. Never pass through the surface. Okay, absorb on surface on collision with catalyst. So which means something like this. You put catalyst, and then the reactant 1 will come here, then the reactant 2 will come here. So when they stick on the catalyst, they meet each other. And then they react. Then they form product. Okay, they form product, then they go away from the catalyst. Okay, so that is a catalyst which acts as platform. where they form chemical bond here and at the same time they meet each other. So let's see here. Molecule rearrangement occurs. Bond in reactant break and new bond in product form. So the reactant come to the surface, at the same time they meet each other, then they form new chemical bonds. Then certain chemical bonds are broken. And product molecule dissolve from surface. So after they form product, then they come out from the catalyst, come out from the surface, and that means this chemical bond broken. Okay, so that is called desorption. Desorb. Okay, so this is the particular term, absorption and desorption. So we have desorption here. Now next one, rate of reaction dependent on surface area of catalyst. So it depends on different thing. Just now, it depends on the concentration of reactant and catalyst. Now it depends on the surface area of catalyst. So absorption is where weak bond form between reactant molecule and surface of catalyst. So which is this bond? This bond is a weak bond. So they form bond here and so that the reactant can meet each other and then they react. After react, they form product and then they go through desorption, releasing of product molecules from surface of catalyst and diffusion away from the surface. So this one, make sure you know intermediate. This one, absorption, desorption. So they have different important terms for each type of catalytic reaction here. So let us move on. Examples of heterogeneous catalysis. Iron in Haber process. Okay, so let's see, we zoom a bit. The pictures is a bit small. Okay, now let's see here. So iron is the solid, and then N2 and H2 is the gas. So they are having different physical states. So you look at the picture first. The iron catalyst provide a platform. Hydrogen will come and form chemical bond with the iron. Nitrogen will come and form chemical bond with the iron. So when they form chemical bond with the ions, so they are at the same time getting nearer to each other. So they may form new bond, for example, between N and H. Then end up with they form ammonia. Ammonia could no longer stick to the catalyst. Then the desorption happen. Desorption and come out from the catalyst. Okay, so these are the whole process. And now let's see the point here. Diffusions are N2 and H2 to the surface of iron. That means they come to the iron. And then absorption happens. Bonds form between reactant and ions, strong enough to weaken covalent bonds within N2 and H2, weak enough to break and allow product to leave. Okay, so that means they will form new bond and at the same time break down the original bond. Okay, but they are not leaving yet. They are trying to tell you they are not leaving yet. Okay, so now reactions. Absorb N and H atoms react to form ammonia. Then desorption. Bond break between NH3 and surface. So they leave away as ammonia. Diffusions of ammonia away from surface of iron. So these are the whole process. Okay, now let's move on. The last part already. Transition elements in catalytic converter. So this is an example of the heterogeneous catalysis. So as you know, the transition element here is solid, but the reactant here are gases. So first, you can see honeycomb structures containing small beads coated with platinum, palladium, and rhodium. So these are the catalysts. So the catalyst is in between. The structures is like honeycomb. Okay, so where just imagine the place where the honey store by the bees. So the structures is like that. So many holes in between. The gas passes through. So the harmful gas passes through the honeycomb structures. Okay, so passes through many holes and then meet up with the catalyst at the same time. So the catalyst provides a phase for this harmful gas to absorb on it. Okay, so the harmful gas absorb on the catalyst. Now, the possible catalytic reactions or the possible catalytic process is the absorption of nitrogen oxides and carbon monoxides, and then the weakening of covalent bonds within nitrogen oxides and carbon monoxides. So weaken the bonds and formations of new bond between adjacent N atoms form N2. So the N and the N will form N2. The CO and the O will form CO2. And then desorption happens and release from the catalyst to form something which is more environmental friendly, N2 and CO2.